So if you clicked on this video, that means that you're a little bit stuck on 16. This problem isn't anything different from the ones you're doing before. It just requires you to write out a full chemical reaction, predict the products, then do a gram-to-gram stoichiometry conversion. So let's start on it. Zinc reacts with silver nitrate. If 18.6 grams of zinc react, how many grams of silver form? So we're going to be going from, as I said, grams of silver into grams of another element, zinc. That is going to be acting as our mass of X and then our mass of Y. So if you really think about what the problem's starting with, our given is the fact that we have 18.6 grams of zinc. So our starting point is going to be over here on the map. We're in mass of X right now. How many grams of silver form? That is our unknown. We are going to be looking for, I'm going to put a question mark over that, mass of Y. So this is going to be our grams of silver, or Ag here, that we are looking for. So to get this problem started, before we do any stoichiometry, we just came out of a whole long chemical reactions unit in order for us to get from mass of X, which is our starting element of zinc, all the way over here to our mass of Y, which is our ending element silver. It looks like we are going to need to go and use a mole ratio at some point through the problem. And if you read on the stoich map, that is from a chemical equation that we write out. So step number one is, if you're never given the full equation, like you kind of saw in the first few problems, you have to go ahead and write out a balanced chemical equation with correct chemical formulas. So let's go ahead and do that. So it says zinc is reacting with silver nitrate. So we know that zinc, the chemical symbol of that is Zn. Silver nitrate, we might need to consult a periodic table to figure out what that formula is. I know off the top of my head that silver is at least Ag. Now, nitrate ends in ATE, and that means it comes from the back of your periodic table here on your common ion sheet. Nitrate's chemical formula is NO3 minus 1. Now, if I go back to that periodic table and look on the cation side for the charge of silver, silver has a charge of +1. So in this case, it just so happens that this chemical formula is already balanced for charge. So AgNO3 is going to be our formula for silver nitrate. Zinc, since it's an element on its own, has no charge. All we have to do then is write Zn. Now at this point, I'm not writing in states of matter because my focus is on the stoichiometry, but if you're curious, this would be solid zinc, and this would be an aqueous solution of silver nitrate. But for the context of our stoich unit, if you don't write in states of matter, no worries. Okay, now, here's where the last unit comes into play. What kind of reaction is this? Well, what I see is I see an element on its own, and I see a compound. So the reaction pattern is we kind of have our A plus BC pattern, which means that we're going to be doing a single replacement reaction. Zinc is going to kick out the less reactive silver, and silver is going to become elemental silver, and zinc is going to join nitrate in a compound. So we're going to put zinc and nitrate together first. Again, it doesn't matter which order you do this. You can do the silver on its own first, then the zinc and nitrate compound. Either one is fine. In this case, if I take a look at my charge sheet one more time, I can see that zinc has a +2 charge. Since nitrate, as we just said, had a -1 charge, what I need to do is use 2 nitrates. Now my charge is equal to 0 in that compound overall. Silver is an element on its own, and that's going to have no charge. Now, is this a balanced chemical equation? The answer, you should say, is no, because over here I have 2 nitrates, over here I only have 1. So what I need to do is I need to use some coefficients, or big numbers, to balance my numbers of atoms on either side of the equation. So I'm going to put a 2 in front of AgNO3, and then I'll put a 2 in front of the silver over here. This way we have 1 zinc, 2 silvers, and 2 nitrates on either side. Now what I need to do is I need to go ahead and start the actual stoichiometry problem. I said we had 18.6 grams of zinc. So I'm going to label that here with the element so that I know which element I'm starting with. I'm going to put that over 1. Now, if I take a look at my stoichiometry map, I'm here. I need to get to moles of X, which is my moles of zinc. That is going to require a molar mass of X. Well, knowing what we know is how do I convert from moles to grams? I know that 1 mole of zinc is equal to a certain number of grams of zinc. Now, where do I find that information? Well, I can find that information on my periodic table, on the front side this time. Going out to 2 decimal places, our molar mass is going to be 65.38 grams. Now, keeping up with what's happened, grams of zinc have gone ahead and canceled. Now we're in moles of zinc. I need to get, if I take a look at my stoich map, from moles of X, which is my zinc as a reminder, into moles of Y, which is going to be my silver, in order to get to eventually grams of Y. So I need to use a mole-to-mole ratio for my balanced chemical equation. Luckily, we just went ahead and balanced that chemical equation, so that shouldn't be too hard for us to figure out. If I look at my chemical equation, there is no coefficient in front of zinc, which means that there is a hidden coefficient of 1. So every 1 mole of zinc, take a look at what I'm trying to find. I'm trying to find grams of silver, so I need to find moles of silver. 2 moles of silver. So keeping track with what we did, we canceled out moles of zinc, and now we're in moles of silver. Am I done yet? Well, no, because I'm still in moles of silver. The question asked me to find grams, or a mass, of silver. So I have one more step that I need to do, and that step is to go from moles of Y into a mass of Y, or moles of silver into a mass of silver, using my molar mass of silver. So since my unit is moles on the top, I know that my moles of silver need to be on the bottom. What is the mass of 1 mole of silver? Of course, we don't expect you to memorize that information, but we can find that right here on the periodic table, right below this elemental symbol for silver. 107.87 grams. Take a look at what just happened. Moles of silver have canceled, and I'm left with grams of silver. At this point, I am left with the unit I want, which was my mass of silver. Let's go ahead and put this into my calculator. So when I put this into my calculator, we are going to start by taking our first number, which is 18.6. We're going to multiply that by the next top number, which is 1, then the 2, then the 107.87 grams. I like to get that answer, press the divide button, make sure you put these next series of numbers into parentheses. In this case, it won't matter either way, but it's a good habit to get in case you have multiple numbers in the denominators of your fractions. It keeps you from screwing up your order of operations. We're going to go 1 times 65.38 times 1 times 1. Enter. And you get this answer of 61.3760171,306, which is a bunch of zeros and decimals and all that stuff. I'm just going to record down the first 2, and we'll decide on what to do with sig figs once I have this answer kind of written here. Okay, so we have around 61.37 grams of silver. Now in this case, if you look at my answer key for number 16, it says 61.4. So it appears that you round this to 3 sig figs. How do I know to round this to 3 sig figs? I tell students to look at your given number and use that to determine the number of sig figs in your answer. Well, 18.6 has 3 sig figs. So what I will do is look at my 1, 2, 3 sig figs in this number, set up my little chopping block. Since 7 is greater than 5, we're going to round that up to 61.4 grams of Ag to match that final answer on number 16. hopefully this helps. Have fun.